Very good. Good afternoon, ladies and gentlemen. I want to now widen the scope again and talk about energy intelligent societies and especially the technologies needed in those. Well, if you look at the global energy transitions underway, they have one common or two common themes. One is raising the energy efficiency, and we're looking more and more at systemic efficiency, cutting across infrastructures, cutting across energy carriers, and we are in basically all countries raising the share of renewable intake. And for physical reasons, this is in most countries solar or wind power, so we are looking more and more towards variable input from renewable power generation, and we are looking at a more and more solid state grid. Coming back to what Olivier said before, this raises issues around stability, but I agree with him, these can be solved. Now I've structured my presentation in these three parts. I talk about firstly the trends and phrase this in all electric agile energy world, knowing that we will not base everything on electrical energy, but electrical energy will be the key energy carrier for various reasons. And secondly, I'll touch down on innovations and technologies and give an outlook where the system is heading. You may have seen that before in the first session this morning. Cedric Neike showed where end consumption is in the European Union, and it varies a little bit from region to region globally, but basically a major share of energy end usage is in heating or cooling infrastructures, including process heat and in transportation. Just to give you an indication about heating infrastructures in Germany, a third of end usage is space heating of houses and buildings. That's more than the end usage of direct electrical energy. So in order to reach sustainable infrastructures, as the previous speakers mentioned, what we will see is more and more cutting across from the electrical sector into the transportation sector by direct electrification, battery-based mobility, for example, or also coupling into hydrogen and then utilizing green fuels, for example. I'll come to that in a moment. We are also seeing more and more crossing over or couplings from the electricity sector into the heating and cooling sector. As you know, water or stones or building structures are excellent heat storage devices or equipments. And therefore, in many countries, we are seeing that, for example, large water tanks are being utilized to store heat or cooling. Even ice storage has been utilized for buildings. What is being needed? Three topics, as the previous speakers mentioned. We have that need for more and more flexibility. And one driver of that is the variable intake. To give you a number, in Germany we have at the moment 60 gigawatt of installed wind power and around about 48 gigawatt of installed photovoltaic power plants. So that's more than 100 gigawatt of variable renewable intake. At times we have a lot of that, and at other times not. At the moment it's 45%. As we are speaking, 45% of electrical energy in Germany is covered by renewable energy, and most of it is wind power. As you just heard, we also have rainy conditions in Germany today. So flexibility being provided by storage. Previous speakers mentioned, for example, battery storage. With storage, we should also, when you talk about storage, also consider the couplings, for example, into heating, cooling. As I mentioned, we have the well-established pumped hydro, and there are also other storage types. Now we are seeing more and more virtual power plants being set up. I'll come to that later. Virtual power plants combining even very small power generations like individual residential photovoltaic power plants, storage, dispatchable loads, and so on. And that is very close to so-called demand response teams. And when we talk about demand response and virtual power plants, that's also very close to microgrids or microgridability. These are actually already working on a commercial basis in various countries, and there's a lot of investigation research going on, including in the field of blockchain technology. In the future, we'll still have the molecules in the system. Therefore, there is a lot of R&D activity in for example, turning gas-fired power plants, being gas engines, gas turbines, into the ability of high hydrogen content of the gases. Secondly, besides flexibility, as I mentioned, we'll see more and more cutting into the other sectors in order to decarbonize them, and at the same time they provide flexibility. Talking about cutting across into hydrogen, into green hydrogen, this has then various applications, and there are quite exciting projects starting or having started globally. For example, in industry, there are a number of steel manufacturers who are setting up hydrogen-based steel manufacturing instead of utilizing coal. In the mobility sector, there are also various projects where fuel cell-based locomotives, for example, are being prototyped. And of course, there's always the application of re-electrification, either with a certain content of hydrogen in the gas, or even 100% gas turbines, for example. Thirdly, and that's a big enabler, and I would say also an accelerator of all these trends, it's the digitalization. What we are seeing is more and more sensors being embedded in our infrastructures, but also not only sensors, but analytics, processing power, even in small switches, and then connectivity. This leads to a very agile infrastructure where even the things can and are already connecting with each other on a field level, for example, in a factory floor. So that data need not be sent into a data cloud. We will see that a lot of organization is and will take place in local, on local basis, in buildings, for example, in factories, and it's quite exciting discussion. What will be the future? How will we organize, for example, our electricity system in the future? Will we have like local cells organizing themselves, hooking up to other cells, and then we have an overall control system, making sure that the system is governed stable. I'll come to that at the end of my presentation. So let's have a look at some of the technologies. I've sketched here a number of those. On the bottom you see, let's say, the hardware technologies, but again, they are more and more equipped with sensors, with analytics, and with power electronics, and quite exciting things going on in the power electronics domain. For example, silicon carbide-based semiconductors are now in the market. You see them in electric cars, you see them in photovoltaic inverters. They mean more compact electronics, more efficient electronics. Storage was already mentioned, distributed energy systems, e-mobility, connected e-mobility, and then on the upper part, you see topics from the data domain. We are setting up digital twins of infrastructures, and those digital twins in the future will get connected. We are also setting up digital twins of materials, so incorporating circular economy aspects, as was mentioned before. All this data analytics, artificial intelligence, means that we are able to develop significantly faster also hardware equipment than before. Just one topic is generative design methodologies. I should also mention security issues and also cyber security issues. This always comes along now with the future developments. Couple of examples. Here's a prototype of a neural network installed in an intelligent substation coordinating the downstream infrastructure of chargers, electric car vehicle chargers, storage, and other significant loads. So this intelligent substations, where you see the microscaler where the circle is, this gets trained, and that training gets downloaded from the cloud into the local neural network, which then operates the downstream distribution grid. Our buildings, moving on into the grid edge, our buildings are undergoing a quite fast development from automated buildings towards adaptive buildings, which are actually then calling the technician in case there is an issue building up. So prescriptive maintenance is a big topic. On the very right side, you see the number 22 question mark, maybe that's 2025. So very fast developments here. What are aspects? Aspects are, for example, raising the comfort of the people in the building. So enabling them, for example, to set the temperature in their office. It's also about agile usage of buildings. In many buildings, 30% of the space is not being used. So it's also about space efficiency. And studies have pointed out that if we introduce building control and automation technologies, up to 40% of efficiency improvement can be obtained in existing buildings. So this technology evolution that is sketched here does not only apply to new build buildings or campuses, but also to existing buildings. You should not forget that in many countries the building infrastructure is only migrating with 1% per year. So it's of utmost importance that we increase the efficiency of existing buildings and campuses. Well, this is a new housing area, not only housing area, but also commercial area in Vienna. 20,000 housing units are there, and it's a living lab. Here we investigate with partners, for example, what people like, what they don't like. So it's a lot about also social analysis, and it's about interaction. This is the era of consumer centricity. Cello was already mentioned before. Finland is in a way is spearheading the digitalization of the grid edge with respect to virtual power plant technologies. And this is a perfect example where not only an existing campus is being equipped with distributed generation, storage, and latest automation technology, but also an example for a very clever integration in the surrounding energy system. And it pays off, as you can see here in the numbers, not only saving CO2 emissions, but also gaining money. And it provides needed flexibility for the grid operator. Now, where does this head towards? I sketched this with this cell picture. Yeah, we are running towards an energy system where our residential homes become complete energy systems themselves. Just one number from Germany: every second newly built residential PV systems gets right away equipped with battery storage. Every second in Germany. In Bavaria, it's even 80%. So, and these PV battery systems are often combined with e-car chargers, with home energy management systems, and there are new business models now that have been set up where such energy systems are integrated into a swarm. So this may be done with blockchain or without blockchain, but it's not the isolated optimization of a household, of a building, of a campus, of industry. It's the overall energy system optimization. We are running, and there are the three, you can say grids important. It's electricity, it's gas. The world will not work without gas in the future. Just think about our industry needing molecules, for example, or for providing a backup power. And it's the digital grid or digital layer. We could discuss that. Now, what is the characterization of the system we are running into? It's that transition from automated infrastructures into semi-autonomous or autonomous infrastructure. It's the digitalization topic, and again, this is not only needed for controlling the system, but it's also accelerating the developments. And we are seeing new roles, for example, platform facilitators. There's a lot of business innovation going on globally. Yeah, with those words, I want to close, and I'm looking very much forward to the discussion that we'll have after the coffee break, I think. Thank you very much. Thank you.